Tēnā koutou. My name is Loretta Garrett from Scion, and today I'll present on spectroscopy to provide a rapid measure of site fertility in planted forests. The outline of the talk today will start with what is reflectance spectroscopy, what can be predicted for foliage and soil chemical analyses, how spectroscopy has enabled decision-making, and when spectroscopy will be ready for forest industry use. Spectroscopy is all about increasing the volume and flow of data in order to make better management decisions. The technology has been around for a while and is highly used by other industries. It has been successfully applied to soil and crop foliage fertility measures, and is a way of moving away from the wet chemistry laboratory to increase our throughput of samples with accurate and precise predictions. This is the electromagnetic spectrum. You will be familiar with the visible section of the spectrum, which shows up as rainbow colours. Reflectance spectroscopy is focused on the visible to mid-infrared range of the electromagnetic spectrum. The mid-infrared range gives the best detail for soil chemical property predictions and is the focus of our work. The basics of how this works is by shining a light beam onto a sample. This then interacts with all the particles and chemical bonds within the sample. Some light is absorbed and the rest is reflected in all directions, which an instrument detector then measures. Different chemical bonds within the sample will give specific spectral signals, allowing us to know what is in the sample and how much of it is there. How do we go about building soil and foliar chemical property predictions? We start with archived soil and foliar samples from our National Planted Forest Archive and associated chemical analytical data. For example, the percent of carbon within a sample. We then take the sample and measure it on a high throughput infrared instrument, which produces a mid-infrared spectra that is unique to that sample. The spectra is used to predict chemical properties using multivariate analysis, and we can compare how well we do by correlating with our measured analytical data. This work that we are doing is supported by our collaboration with Dr. Jonathan Sandeman, who is an international expert in using soil spectroscopy to predict a number of soil chemical properties. Many soil properties can be predicted well by mid-infrared spectroscopy. This table shows work that our collaborator, Dr. Jonathan Sandeman, has done with the US National Soil Survey Center Mid-Infrared Spectral Library, made up of more than 75,000 soil samples, and they are able to predict over 20 properties from one scan. Tree foliage is less well developed, but shows promise with conifer trees. This example is for a small data set, and the ability to predict chemical properties is good. Then, with any new sample that is collected with no analytical data, we can measure it in a high throughput infrared instrument and predict multiple properties from one spectral scan. We can use spectroscopy to increase the volume and flow of data and build large data sets for any given area for lower cost than traditional analysis methods. This is because with one spectral scan, we can predict multiple properties. We can then make detailed maps to underpin nutritional management zones, for example. The lack of high resolution spatial soil data in particular is a current limitation on informed decision making. Detailed spatial soil and foliar understanding should improve productivity modelling through to forest health and wood quality property predictions. For example, what is the role of soil micronutrients on tree growth, health, and timber products? This level of detail is only made possible with high volume and flow of soil and foliar data, which can be achieved through spectroscopy. So when will spectroscopy testing be ready? By late 2021, next year, the soil and foliar spectral predictions will be ready to use. We have 3 steps to do. We're currently piloting the technology with New Zealand soil and foliar samples. We will then increase the library of soil and foliar samples for improved predictions and then publish the findings. You can support the second step by adding your soil and foliar sample to the library. Ensure that your forest is within the training dataset. If you're interested in this, please connect with me. Ngā mihi.